Okay, welcome back, everybody. And today we're going to talk about some coordinate geometry. We're going to spend a lot more time with this later in the class, but we're going to just introduce it today. And also, we're going to tell you about two formulas that we need in our work for this lesson. One is the midpoint formula, and one is the distance formula. So you'll recall that the coordinate system is divided up into four quadrants by the x-axis and the y-axis. So the x-axis is horizontal, the y-axis is vertical. Upper right-hand corner is quadrant one, and then we go counterclockwise, naming the quadrants. So quadrant 1, 2, 3, and 4 counterclockwise using Roman numerals. Okay, so the purpose of the coordinate system is to be able to give coordinates of points and locate the location of points in the coordinate system. So if we just have any point, let's just say this one right here, it'll have two coordinates. It'll have an x-coordinate come first, and it'll have a y-coordinate come second. So they're separated by a comma. The x-coordinate tells you how far to the right or left of the y-axis your point lies, and the y-coordinate tells you how far up, below, or above the x-axis that your point lies. So in the case right here, this point right here is going to have the coordinates of 1, 2, 3, 4, positive 5, because the point lies 5 to the right of the y-axis. It would be negative number if that point was to the left of the y-axis, and the y-coordinate would be positive 3 because it lies 3 squares above the x-axis, and it would be negative if the point lies below the x-axis. So that's the coordinate system. So our job today is to use the coordinate system to talk about how to find the midpoint of a line segment. Okay, so let's take, so we're going to look at the midpoint formula. I'm purposely not using graph paper for this because we're going to talk about variables, not just numbers. And we're going to have, when we're done with this, a way to calculate the midpoint of any line segment if you know the endpoints. So let's take a look at just a point in the first, actually a line segment in the first quadrant. So there's your x and y axes. And here's going to be a line segment right here. We'll call that line segment AB. And we're going to be interested in calculating the coordinates of the midpoint of line segment AB, which we'll call M. Okay, so this first point A is going to be, let's just say, x sub 1, y sub 1. So what that means, the subscripts there means we're going to distinguish that from the other point, which we're going to call x sub b is x sub 2, y sub 2. So the subscripts just mean different points. So we're going to calculate then the coordinates of the midpoint. Actually, just give you a formula for that now, and then we'll do an example. So the way you're going to get that midpoint is you're going to average the x-coordinates of the 2 points A and B, and then average the y-coordinates of the 2 points A and B. So average, remember, means that you're going to add two numbers up and then divide by 2. So if I take those two x-coordinates, the x sub 1 and the x sub 1 and the x sub 2, and add them up and divide by 2, I will have x sub 1 plus x sub 2, and then divide that by 2. That's going to help you calculate the x-coordinate of the midpoint. So really, the midpoint is really right in the middle of A and B. So it's like the if you just take those endpoints and average them, that's what you will get for that x-coordinate of the midpoint. And you'll do the same thing for the y-coordinate. It's exactly vertically in between between A and B, and so we'll just average the y-coordinates of A and B. So to do that, again, you just add those two y-coordinates, so y sub 1 plus y sub 2, and divide by 2. And that's all you're doing to calculate the midpoint, is just take the average of the x's and the average of the y's. That will give you the x and y coordinates of the midpoint between the endpoints of that line segment A and B. Okay, how does all that work? Well, let's do an example for that. Show you how that works. All right, so we'll call this example 1, and I'll put a coordinate system on here. You can use the midpoint formula. You don't even need to draw the picture or even have graph paper, but this is just for understanding purposes at this point. All right, let's say we have 2 points. So point C is a -2, -1. So point C is a -2, -1. And point D is at 4, 2. Point D is at 4, 2. So here's your line segment. We want to calculate M. So we want to calculate M, which is the midpoint of segment CD. Okay, so we're just going to do what we already said, and that is to just average the x coordinates and average the y coordinates. So if we take the two x coordinates, that's a -2 plus 4, and divide them by 2. I'll do that in a minute. Now let's add the y coordinates and divide by 2, so -1 plus 2. And once we do the math on that, we will have the coordinates of point M, the midpoint of segment CD. So here we have the top is 2, so 2 divided by 2 is 1. Here we have the top of the fraction is -1 plus 2 is 1, divided by 2 is 1/2. So that point right there, 1 and 1/2, if I just estimate where that is, right there, that's going to be point M. So it's pretty difficult to find that just by looks, so you're going to want to calculate the midpoint. So that's all you do for the midpoint formula. It's just average the x coordinates and average the y coordinates, and you'll have the coordinates of the midpoint. Of course, we can't have that. That's too easy. We gotta move, shake it up a little bit. So let's take this time how to find the coordinates of an endpoint of a line segment if you know one endpoint and then the midpoint. Okay, so we'll call this example 2. And we'll draw the coordinate system again. And let's say this time we have point, okay, let's see. Point A is at 2, 2. So point A right there is at 2, 2. Point M is at 4, -3. So 4 to the right, 3 down. 1, 2, 3. Point M is at 4, -3. So now we got to calculate the coordinates of B. So that's our job, is to find the coordinates of the other endpoint B, the other endpoint of the segment, which we're going to call point B. So we would expect it would be down here somewhere, right? Because you got one endpoint is A, then you draw toward line or point M, and that'll be the midpoint. And then you'll continue on and locate point B. But we don't know exactly where point B is, so that's what we're trying to find. But we do know that point B will have coordinates that we're trying to find. So we'll just call them X and Y because we don't know what they are. Okay, and then we'll use our midpoint formula to actually calculate the coordinates of the other endpoint, point B. So remember that you just average the x's to get that midpoint x coordinate. So if we just take 2 plus x, that's going to give you, and then divide by 2, that's going to equal that 4, right? Because you're adding the x coordinate 2 from point A to the x coordinate from B, which is x, which we don't know. We're looking for that, and then divide by 2. That's equal to the midpoint of the x coordinate of the midpoint. So we'll just solve that. So that's 2 plus x is equal to 8. So x is equal to 6. So we know that the x coordinate of point B is 6. So we can actually write that in there, and we'll graph it after we calculate the y coordinate. We know that's 6 right there. We just calculated it. All right, let's do a similar calculation to find the y-coordinate of point B. So remember that if you take the 2 from point A and add it to the y-coordinate of point B, and then divide by 2, that's going to be equal to the y-coordinate of the midpoint, which is -3 in this case. Let's go ahead and solve that little equation for y. So you got 2 plus y is equal to -6. Then you have y is equal to -8. So now we have the coordinates of point B, the other endpoint of the line segment is 6, -8. And we can go ahead and plot that. So let's see where that is. So 6, -8, so 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8 right here. So there's your line segment where we started with one endpoint and the midpoint and used the midpoint formula actually to calculate the other endpoint. So you can use the midpoint to actually calculate a midpoint if you know the two endpoints of a line segment, or you can use the midpoint formula to calculate one of the missing endpoints if you know the other endpoint and the midpoint. Okay, the other formula we have in this lesson is the distance formula. The distance formula. So the distance formula actually comes from the Pythagorean theorem, which we have not officially had yet this year. I'll give it to you a little bit later, and it'll be proved later, but right now, since we haven't proved it and we really haven't had it this year, I'm just going to give you that distance formula as a formula and then expect you to know how to use it. So the distance formula, its job is to tell you how long a line segment is if you know the endpoints. So here's the distance formula. So you're going to take x sub 2 minus x sub 1. You're going to subtract the two x coordinates of the endpoints and then square. And then you're going to do the same thing for the y coordinates. So y sub 2 minus y sub 1 and then square that. And that's all under a square root. So these problems are going to involve radicals, which you're going to have to remember how to simplify radicals. So there's your distance formula. And again, that comes from the Pythagorean theorem, which we'll explain later when we talk more in depth about the Pythagorean theorem. Right now, basically, all we have to do is know how to use it. All right, so let me give an example for that. And so this will be, I guess we're on example 3. Sometimes I'll lose track. And so we're going to put some points on the coordinate system here. And so one point is A is at 0, 3. So point A is at 0, 3. Point B is at 5, 1. 1, 2, 3, 4, 5, 1. There's point B. Point C is at -1, 1. So here's point C. Coordinates again are -1, 1. And point D is at -3, 4. So 1, 2, 3, 1, 2, 3, 4. So there's point D at -3, 4. So what we're going to do is we're going to find the length of segment AB. So we're going to find this one. We'll find out how long that is using the distance formula. And then we're going to find out how long segment CD is, again, using the distance formula. And then we're going to decide if the two segments are congruent. In other words, if they have the same length. So basically, we have to do the distance formula twice. So I'll do the distance formula on segment AB first. Remember, writing AB without the line symbol on top means the length of it. So we got a big square root problem. So subtract the coordinates. So we got 5, the x coordinates here. So 5 minus 0. You could have also started with 0 minus 5 because you're going to square it. And when you square 5 minus 0, you get the same thing as when you square 0 minus 5. So the order really doesn't matter there. So you can cover up a mistake, actually. but just subtract the x coordinates and square, and then subtract the y coordinates and square. So I did 5 minus 0. Now I'm going to do 1 minus 3 for the y coordinates. Square that. Okay, let's do the math. So that first term under there is 25, right? Because you got 5 squared. The second term under the radical is 1 minus 3 is negative 2 squared is 4. So this ends up to be the square root of 29. I don't care what that decimal is. It doesn't matter. We're just trying to decide if segment AB and segment CD are the same. So we can just leave it as a square root of 29, and the radical does not simplify. Okay, now let's do the same calculation for segment CD. So segment CD equals the square root of. Okay, again, we're going to subtract x coordinates, so it's going to be a negative 3 minus a negative 1, so be careful. A negative 3 minus a negative 1 is negative 3 plus 1. A negative 3 minus a negative 1 is a negative 3 plus 1. Square that. Plus, now let's subtract the y coordinates, so it's a negative 4 minus 1. Negative 4 minus 1. That's going to be squared, and that's all underneath that radical. Okay, let's see how that works out. So the first term under the radical there is negative 2 squared. That's going to be 4. And then the second term under there is a negative 5 squared, which is going to be 25. So if you look at what we have so far, we again come up with the square root of 29. So our conclusion is, if you look at those two segments, is that they're congruent. The segment AB is congruent to segment CD because their lengths are equal, which we found by calculating their lengths by the distance formula. Okay, the last topic we have before we finish, and then we got a couple of worksheets on midpoint and distance formulas. That is to just introduce briefly the Pythagorean theorem. Before I do that, though, we got to talk about what is a right triangle and the parts of a right triangle. So I'm going to draw a right triangle here, and this is, again, probably something you already know. So there's a right triangle. It's a right triangle because it has a right angle. And the two sides of the triangle, the right triangle that form that right angle, are called the legs. So that's a leg of the right triangle. And this is the other leg of a right triangle. So a right triangle has two legs. They are the two legs joined to form the right angle. This third side is called the hypotenuse. And the hypotenuse is two things. It's always across from the right angle, and it is the longest of the three sides of the right triangle. So there's the parts of a right triangle. And so the Pythagorean theorem, which is the most important theorem of this year, and probably the most important theorem of high school for you. So you absolutely have to know and understand the Pythagorean theorem. Named after Pythagoras, even though he was not the first to come up with it. He just got credit for it. I think the Pythagorean theorem was known in China before the Europeans knew it. Pythagoras was an Italian, I believe. In any case, what the Pythagorean theorem simply says is if you have sides of a right triangle A, B, and C, where A and B are the legs and C is the hypotenuse, simply the square of the length of one leg plus the square of the length of the other leg equals the square of the hypotenuse. That can be proved. There's a lot of different ways to prove it. Today we're not going to prove it. We'll deal with that later. But that's Pythagorean theorem, and so we can expect to see much more of that later on this year. Okay, so to kind of summarize what we talked about today, so we talked about the coordinate plane, which is just a way to locate points in the plane. We got an x-axis, y-axis, and 4 quadrants. We did the midpoint formula, which just says if you know the endpoints of a line segment, then you can find the coordinates of the midpoint of that same segment by adding the x's from the endpoints and divided by 2, and then adding the y's of the endpoints and divided by 2. That'll give you the x and y coordinates of the midpoint. And then finally we had the distance formula, which uses the endpoints of a line segment in a formula to calculate how long is that line segment. So finding the length of the line segment. So that's the distance formula. Then finally, we ended up with the parts of a right triangle and the most important theorem of all geometry, which is the Pythagorean theorem, which says in a right triangle, the square of the leg plus the square of the other leg is equal to the square of the longest side, the hypotenuse. Okay, thanks for listening. That's your lesson for today.